tight agenda today. Once again, welcome everyone. Thank you very much for being here with us today. This is the SNS Eyes and Guide webinar on automotive transport and logistics solutions, where we're going to have a look at the active research and innovation actions ongoing from SNS side with regards to transport and logistics and automotive solutions, and also hear from the CEF side what are the open projects and current opportunities, and also have an opportunity to connect with colleagues on this vertical from 5G AA and Vertical. So we're looking forward to a very nice discussion where we'll hopefully sync and we're all on the same page to discuss what are the key issues in this area. Let me start by then quickly going over some guidelines for today's event. So this event will be recorded, as we'd like to make this available later on via the page to anyone who couldn't join us here today. In order to facilitate things during the day, please keep your microphone muted at all times. If you're not presenting, the presentations along with the recording of the event will be available at the event page, which you already used to register. And please use the chat box to ask any questions you might have for the speakers, also identifying the speaker, and we will try to address all of them during the Q&A slots at the end. So with that said, let me share with you the agenda. And first of all, apologies, I forgot to introduce myself. So my name is Kostas Trichias. I'm with the SIG GIA, and I'm also the coordinator of the SNS ICE project. And together with my colleague, Pierre Danet, we're going to be hosting this event from the SNS side. And we have with us David Kennedy and Laura Sanz from the Guide project, who have helped us organize this and co-host with us. So during today's event, we're going to hear from 5G, AA, and Vertical regarding the roadmap and their activities on the road. We're going to hear from the Guide project with regards to the current status of the CEF program and the activities ongoing there. And then we're going to hear about the activities of 4 of the active SNS JU projects, namely Envelope, Target X, Transnet, and 6G DSAC, as to what they are currently working on and looking at with regards to this vertical. And then at the end, we're going to have a Q&A session. It's going to be moderated by my colleague Pierre. Many thanks to all of you for being here, and especially to Dinos from Envelope, as this slot was very inconvenient for them, but in order to facilitate the event, he was able to join, although he might not be available for the Q&A. Now, before I give the floor to the first presenter, let me maybe go over, let's say, what we've been the road so far. There's been a great effort on 5G for CAM projects, either for automotive or transport logistics or even for waterways. It has already started from the 5G PPP era back in 2018, with multiple projects being funded there to start researching various angles of this, and with a dream to realize the transport corridors across Europe. This has significantly evolved over the 5G PPP, with multiple projects taking over and looking at different aspects. And there is a continuation of this trend into this vertical for automotive and transport logistics, with additional projects in the SNS JU, already from Call 1 in 2023, but also newer projects from 2024. 5 projects so far are working on it. 4 of them will be presenting here today. In parallel, besides the research and innovation actions taking place, there is, of course, the CEF program, the Connecting Europe Facility, where multiple projects to study and to implement and help the deployment of 5G solutions across European transport corridors are already underway. You can see on the map here all the current initiatives in terms of works and studies that are happening. And of course, this is not done. Actually, the 4th CEF digital call is now open with a deadline of for 13th of February. I think colleague David will say a few more words about this towards the end of the event. So there's a lot of work going on here, and what we'd like to do with today's event is see where do we stand now, what is the current work going on in both research and innovation and deployment activities, and to link with our colleagues in the vertical associations. With that said, let's move ahead. Please enjoy the event. I'll give the floor to my colleague Pierre, who's going to be moderating the sessions, to maybe start with our first speaker. I'm not sure if Maxime, you're with us.
Well, yes. So good afternoon, everyone. Yes, it seems that Maxime is not still there. So maybe we can start with Koen from Ertico. So Koen, if you can share your screen and make the presentation. So sorry for the change of the agenda, but I think so we can.
I need to find the right one then. Just a sec. It's a little bit faster than expected.
Yeah, I know that. So if you can to keep the time, so we have a number of presentations today, so it's 5 minutes per presentation. If you can,
yeah, I'll
advise you
10 minutes, right?
Yes.
Oh, interesting. There's a new WebEx version, so I'm not allowed to share my screen on a Mac. Let's have a look. I can't share my screen currently. For that, I need to get out of the meeting and join in again. I was expecting that you would do it because I provided my presentation. I don't know if that's possible.
I can do it for you, Koen, if that would speed things up.
That helps.
Okay, and let me.
macOS does this sometimes. Say you've been out for too long.
Problem. So should be coming on now.
Yes.
Is that okay?
Presentation mode. Yeah, I see it.
Perfect.
Okay. So because Ertico is doing a lot, really a lot, I try to give you an overview of what we're all doing and see if that puts you into a position that you have any questions or any remarks or you want to learn more. That's the setup of this presentation. If you can go to the next. Briefly, what Ertico does is we try to bring intelligence into mobility towards sustainable mobility, efficient mobility, and safe mobility. And we do that by developing, promoting, deploying intelligent mobility services with all our partners and the platforms that we host. Can you go to the next? So you look at innovation in a general manner. Maybe click again because there's an animation indeed. You see all these different topics: automated driving, drones, data exchange, traffic management, navigation, micromobility, safety, the intelligent infrastructure, which is related to guide. These are all V2X communications. The same. These are all topics that need to work together within an ecosystem. So there's actually a serious amount of different topics and a serious amount of different partners that we need to engage to ensure that we create innovation through ITS. Can you go to the next? To help us out, we have 4 focus areas, so connected to pop-driven automated driving. In here is also the cross-border connectivity. You have clean and eco-mobility, ensuring that everything is green and clean, of course. Urban mobility and mass, and transport and logistics. These are the areas that we try to find projects and programs and try to develop platforms, cooperation platforms across Europe to ensure that we move into zero impact, zero delays, and zero accidents. Can you go to the next? To support that, we have several activities. One of the activities you might know is the ITS congresses, focus on events. City Moonshot is an interesting survey amongst 250 cities to see what they actually want. EU-funded projects and innovation platforms, there you should know, as international cooperation, communication, marketing, advocacy, everything we learn, we try to feed into the EU so that the entire European Union progresses into a certain direction. And cross-sector dialogue. So we facilitate discussions between MNOs, OEMs, ITS industry, etc. Can you go to the next? This leads to a whole bunch of projects. I'm not going to run through them, but this gives you an overview of the type of projects that are running. So FAME, you should know. Guide, of course, has been mentioned. There are others. 5G Mobiles was one of that as well, but it's closed. Other interesting ones to mention are SHOW, most of you very likely know. Deploy MDS is a very relevant one to share here. SUM as well, which focuses on sustainable urban mobility plans. Can you go to the next? So it's a lot. And actually, we already closed a lot as well. So here's Arcade, predecessor of Fame, 5G Loginov, 5G Mobix is here. That's the one that led us to Guide in the end. A whole bunch of projects that we created. Ideally, if you have a project and a collaboration that works and there's an uptick, we try to create cross-sectoral discussions in platforms. That's on the next slide. Between partners that are not necessarily ethical partners. Okay, can you go to the next slide? Those are the platforms that we try to do. I'm co-chair of TM 2.0, in which we try to create a collaboration between traffic management and the actual travelers. For example, TISA feeds into standards that allow the communication between traffic management centers and navigation systems. Sensores is one of the main feeds into data for road safety. EAVP platform tries to come to a standard on how to support valet parking across Europe. MAS Alliance is an alliance in which we try to find collaboration between MAS participants and to create mobility as a service, basically. Can you go to the next? If you look at the deployment, this is a picture of the deployment. You see all these earlier mentioned platforms in a picture, in architecture. So we have Sensores, goes to cloud, to a service cloud. We have the service provider maps. They are communicated through TISA to vehicles. Then we have the TMC communication, which is communicated through TNITS towards the service provider maps. MAS, in the end, moves into the vehicle, makes the link with the person, and so on and so on. So this whole architecture, this whole map is supported by actually a lot of vertical platforms. Can you go to the next? Another interesting and free thing for you is to look at the Intelligent Transport Systems Market Radar. What we try to do once in a while is to have a survey or have an assessment of, okay, where's the market? What's coming up? What's there? Where can I focus on? Where can I find my investment point? You can download this if you want. You can read it, and this will provide you some insights on where the current European market is. Can you go to the next?
Okay, if you can so summarize the coin, I think that you are at the end of the 5 minutes.
Almost there, yeah, indeed. I mentioned this. You can go to the next. The Ethico Academy, in the end, everything we learn in projects, we try to place in an academy for which you can create, find courses to follow. If you go to the next, it's an overview of MAS. What you see is the market usually works in a winner-takes-all manner, which is easy, logical. If you have all, then it's good. But ideally, there's an open ecosystem approach, and we try to do that in all our platforms and all our projects, hence the platforms. And I think that if you can go to slide 16, Kostas, then that would be the last one. That's not this one. Next one. So if you want to follow us, if you want to learn of the things that we do, keep track of where the state of ITS is, then follow us on any of these channels that you want, or contact any of the colleagues that you might know. Thank you.
Okay.
I hope it was in the 10 minutes, right?
Yeah, very good. Very good. So I'm afraid that Maxime is still not online, so maybe we can so continue on the agenda with Laura from I2CAT. Laura, if you can take the floor and share your presentation.
Sure. Thank you, Pierre, and thank you, Costa. Good afternoon, everyone. I aim to share the presentation now. Let me know whenever you...
It's okay. See if you can put in...
Yes, in presentation.
Screen.
Do in a second. Let me know if you can see it already in presentation mode.
Yes, very good.
Great.
Yeah.
Great. So again, good afternoon, everyone. I'm Laura Sanz from I2CAT and also partner of the Guide Coordination and Support Action. Today, what I will explain is, I will briefly introduce the Guide CSA, since it's part of deployment, so it's slightly different to other projects that are being presented today in this session, but also mostly I will talk about the 5G strategic deployment agenda for connected and automated mobility, which is one of the missions of this Guide Coordination and Support Action. I don't know why. Now, I should have jump to the next slide. I hope you can see it as well. So basically, GUIDE is a coordination and support action that aims to bring the ecosystem of players that are important actors for the deployment of 5G for connected and automated mobility in order to facilitate the discussions about actual deployment. No, it aims also to support the 5G corridors projects under the CEF program. And also gather lessons learned from these projects and come up with a set of best practices for future deployment. At the same time, it will help also to build a project pipeline. One of the missions, as I said, of this CSA is the 5G Strategic Deployment Agenda for Connected and Automated Mobility. We are working here on a strategic document, okay, that aims to provide a vision about an evolutionary path for deployment of 5G for CAM by basically looking into identifying what are the priority services that will benefit from 5G, okay, what are the requirements of these services from network point of view. We are talking here about what is the performance, what is the quality needed, and so on. And basically also to provide an understanding of the market as it is. Now, what are the main stakeholders in the ecosystem? What is the regulatory and policy context we are moving in? What are the possible cooperation models, deployment options, and so on. I will focus the presentation on road, okay, but I wanted to simply mention that when we are talking about the 5G SDA for CAM, we are basically talking right now about two different transport modes. Okay, the 5G SDA for rail. This has been also under the umbrella of the mission, with specific organizations working on it. The 5G for road and the 5G SDA for road, and the commonalities and joint opportunities between both transport modes. Okay, simply to mention, okay, the 5G SDA for rail, I will not focus on this, but it's already available. So I hope you can have a look at it in the link that will be provided in the presentation. And then for the 5G SDA for road, what are the opportunities? What are the services we are considering? No, we are considering basically two categories that basically are related to the ones that can benefit from connectivity to provide safety and traffic efficiency, and where connectivity and related technologies are key enablers to enhance or to enable these services. And here we basically are talking about how highly automated driving can benefit also from 5G, about for instance, remote driving and how this will enable new opportunities, about smart traffic management. So we are talking about this category, and then the connected passenger services, which basically are more about how passengers or users of the services can directly benefit from 5G in terms of infotainment or navigation or multimedia, communication, entertainment, and so on. There are some services also that will be considered, like, for instance, mutualization with transport-related services, no? How 5G, at the same time that it helps in this category of services, can also help in others, like, for instance, construction works or similar services in roads, no? So this is also something we will look at. And basically, what are the challenges that we want to evolve or solve with this strategic deployment agenda? The challenge is to come up with a harmonized service deployment roadmap, a consolidated service deployment roadmap, to come up with a list or a reflection on what are the most suitable cooperation models among stakeholders that can help in making the business models more feasible or more cost efficient, and what are the most feasible deployment options, as well as coming up with a rough timeline, guidelines, and so on. About the harmonized service deployment roadmap, what we have in the ecosystem right now is different expert organizations that have their own deployment roadmap, like the one provided by 5GAA ERTIC also has a visionary roadmap. AirTrack also covering and talking about the SICAM use cases, not to forget here the CITS players and their own initiatives and activities with also their own perspective about this roadmap. And the point is that there is not consolidated one, but still the promoters of this agenda need to come up with a proposal about what are the prioritized services, okay, and what are the most prominent ones, okay, what are the ones we are deploying today, but what are the ones that we need to deploy with priority and will need the 5G, as well as service requirements, as I said, and necessary building blocks or innovations in order to fulfill these requirements. Something that we need to reflect on is what are what is the level of use, what is going to be the level of use of these services, the market uptake, the user demand figures, and so on. Then the cooperation models. This is about basically how the stakeholders will interact to come up with feasible business models. And here we are talking about how the investment will happen, if there is any possibility of network setting options, contractual agreements, and so on in order to make this, as I said, feasible business models. What we see here is the three main nowadays actors that are involved in the business models, which is the communication service providers, MNOs, and neutral host or tower companies, original equipment manufacturers, road operators. But as soon as we get into more complex services, there will be new actors involved here, and we need to take this into account. Currently, there are different models already identified by summarized by some organizations, and we need to also explore the feedback from the current CEF 5G corridors on these suggested cooperation models or others, as well as national initiatives that can also be working on additional interaction or cooperation options. And about deployment, we need to come up with suggestions, best practices, planning, rough timeline, okay? And with this, basically, this will integrate what are the feasible business models, what is the optimal cooperation options and contractual relation between the stakeholders. We want to incorporate best practices from the ongoing corridors projects, okay? Basically, there are already 5G corridors projects in call 1 and call 2 with 7 corridors projects selected under the call 3, not all are for road. 4 of them are road based, okay? Unfortunately, we cannot see very well the names here, but I provided the links for the people interested to have a look at it. And of course, we need to provide recommendations for public funded, what are the suggestions for funding in the future, and how we can encourage private investments. And I will finalize my presentation with this last slide that basically is an overview on how to move forward and to remove these and to tackle these challenges, remove these barriers. So to mention again, the engagement by all the stakeholders is important in order to unblock the situation, how to proceed, what are the services, how to plan for this 5G investment in 5G deployment. The feedback from the corridors in order to come up with these lessons learned and to build this project pipeline. And very important, the commonalities. This brings new opportunities, the commonalities across transport modes that now will happen with the rail community, but will extend to other transport modes. This is the idea, and will help us to come up with these joint opportunities to maximize the investments to make it more efficient. And with this, I reach the end of the presentation. Thank you very much.
Okay, thank you, Laura. So just in time, very good. So maybe we can go ahead with Dinos, with the envelope project. So Dinos, if you can take the floor and share your presentation.
Yes, hello. Just give me 1 second to share my screen.
Mm-hmm. Okay, fine.
Can you see?
Yes, very good. Thank you.
Okay, great. Thank you for the kind invitation. Hello, everyone. My name is Dinos Katsaros from ICCS in Greece. I coordinate the envelope project, which is focused on the automotive sector. Let me try to. Okay. So what is envelope? Envelope is a StreamD SNS large-scale trials and pilots project focused on the CAM sector, on connected and automated mobility. It has 3 living labs, which I will describe later on, and 23 partners from 10 member state countries. This is, in a nutshell, the overview as a project. Now, the idea behind the envelope on a high-level view is to provide the capability to vertical CCAM applications to begin with, and I will explain what I mean by that, to expose network capabilities for the network, to expose network capabilities to verticals such as the automotive one, to provide vertical information to the network so that we establish a communication between the applications and the network both ways, which also includes the verticals to dynamically request and modify certain network aspects. Again, I will give specific examples of what we mean by that. That is, we provide an envelope, as the project name denotes, that can cover, accommodate, and support any type of vertical service. So what this means in practice, we want to develop novel CAM services and develop easy to use, transparent and open interfaces for the communication of these services with the network. This means, in practice, the reconfiguration of the Beyond 5G system in what concerns NEF and PCF, policy control function, and network exposure function services. Some examples include quality on demand, device location, performance metrics, which means that we establish we request the network to dynamically establish the quality of service that the application requires at the moment, dynamically. This is the key word. We can get the device location and also communicate some key performance metrics to the application. Going even further than that, we provide, we have designed and we have started implementing key Beyond 5G technologies, Beyond 5G in the sense that they offer additional value to the CAM services compared to the baseline 5G architecture. That is ATSSS multi-connectivity, predictive quality of service, and zero-touch management. On top of that, we focus on MEC integration and cross-domain east-west bound coordination like federation or service migration. The key idea is to demonstrate these capabilities through our use cases, but also through the open calls that we are going to host, so that we facilitate third parties to come and validate and show the value of the developed functionality. So the living labs are the Italian one of Links and Politecnico di Torino, 2 base stations for experimentation. I will refer later on to the 2 use cases hosted there. The technical focus is on, of course, on the CCAM service and interaction with the network. For instance, utilizing the quality on demand capabilities exposed by the envelope platform, and also establishing MEC federation and MEC handover support. I will explain later on during the presentation of the use cases what this actually means. We also have the Dutch Living Lab located at the Automotive campus in Helmond. 3 use cases there with a particular focus on digital twins. There, the focus is to engage the digital twin in the support of dynamic network reconfiguration. to expose digital twin information to third parties, meaning other vehicles, other road users, and also to support MEC Federation and handover. Finally, the Greek Living Lab is located at Athens, at NSS JU's campus, and offers the option of having two PLMNs co-located in the same campus, that of NSS JU and OT and MNO. We will focus on a single use case in this trial site, referring to data sharing for real-time situation awareness, which has both traffic flows on the uplink and the downlink. The technical focus there will be on inter-PLMN service continuity, supporting seamless handover and roaming, and the edge service migration. So we'll go from the radio handover to the PDQ session management for the support of the handover and the roaming, up to edge service migration. On top of that, we're developing the predictive quality of service functionality as a service to the experimenter, to a CCAM application practically, and we will focus on ATSSS multi-connectivity. The planned use cases in the Italian Living Lab, we have advanced in-service reporting for automated driving vehicles. So an event, an accident triggers the need to reconstruct the scene based on raw sensor data of the vehicles. This means a dynamic request for the service to be instantiated at the edge location of preference, and at the same time the dynamic quality on demand actually for allocating the resources required for the support of the upload of the data. And of course, MEC Federation is required for the data to flow to neighboring areas and be exchanged and consolidated. In addition to that, we have the dynamic collaborative mapping for automated driving, where vehicles provide HD map updates with similar technological focus, with a differentiation of the focus to make handover, meaning that the service migrates from a server to the other. In the Dutch Living Lab, we have the periodic vehicle data collection for improving digital twin. So we have the vehicle data providing sensor data to the digital twin service, which means that this is a communication that does not take place continuously, but periodically or dynamically subject to what happens on the field, which points to the periodic or dynamic network resource allocation. At the same time, the second use case in the Dutch Living Lab is that of vehicle testing with mixed reality. So the vehicle will collect at the digital twin service vehicle perception data, which are fed back as virtual object to the vehicle for testing purposes, testing of the algorithms that run on a real vehicle. And there we utilize geofenced quality on-demand features, applying certain configurations for certain vehicles depending on their location. The third use case there is that of teleoperated driving aided by digital twin, where vehicle or other road user perception data are delivered to the digital twin service, and there we have both geofenced quality of demand and predictive quality of service to be validated. Finally, in the Greek Living Lab, the application is that of data sharing for real-time situation awareness, where, as the title implies, vehicle perception data are consolidated at an ITS management service. And on the downlink, these data are provided in the form of alerts and notifications to vehicles subject to the circumstances. There, we will test inter-PLMN mobility support, make handover, ATSSS multi-connectivity, and predictive quality of service. And I finish with my last slide regarding open calls. We're going to have 2 rounds of open calls expected later on second quarter of 2025. The high-level goals are to demonstrate the reusability of the developed functionalities interfaces through new use cases and new applications, but also to extend the provided infrastructure with additional functionalities tailored to the needs of other verticals. This means that the enablers that we build are initially aimed to support the automotive sector, but this doesn't mean that there is no room for use or value actually for using these functionalities in other verticals, and so we promote the applications that exactly highlight the value for other vertical sectors. The duration of the projects will be 6 months. The total budget is 2.7 million euro, and we aim at a maximum funding per project, maximum, not necessarily to be reached. It depends on the actual work to be promised, of 300k euros. So that's it on my side. I'm Dinos Katsaros. Feel free to contact me. Apologies for not having time to stay for the Q&A session, but actually now I'm in Budapest for the third plenary meeting of Envelope. Thanks a lot for your time.
I say thank you for your time as well, because I know that it was not easy for you to make this presentation due to your internal project. So thank you, Dinos. Anyway, if people have some question, maybe we can use a mail afterwards offline, to make answers. The question are still welcome on chat. Okay, thank you, Dinos.
Thank you.
Next presentation is from the Target X project. So Jad, you are together with us. If you can share your presentation.
Hello, good afternoon, everyone, and thank you, Jean-Yves, for the invitation. So I'm Jad Nasreddin. I'm senior researcher at I2CAT, and I'm the work package leader for Automotive in Target X. So I'm trying to share my screen. One second, please. Can you see my screen?
Yes.
Okay. So good afternoon. So I will present Target X. And the idea here is that Target X is a SNS project, EU SNS project, a large-scale project that has an objective to digitalize different verticals, mainly energy, manufacturing, construction, and automotive. And also it has a part of 2 open calls that already closed. And we have now the projects of the second open calls that are running. So today I will just focus on the automotive work package and the vertical, and I will present what we are doing, especially the different use cases that we have developed and integrated in the system. So the idea of the automotive vertical in Target X is to be able to demonstrate and evaluate how in fact we can use 5G network in order to overcome the challenges in automotive. And the idea is mainly to focus on the characteristics of automotive that are mobility and safety. And from this, we have derived 3 use cases. The first one is about cooperative perception, the second about digital twin, and the third about predictive quality of service for teleoperated driving. And these 3 use cases are mapped, in fact, to 3 problems. Mainly is idea of showing how interaction between the application and network can be beneficial for enhancing the quality of experience in V2X application. And the second one is to see how collecting information from sensors in the car, LiDARs, videos, are allowing us to deploy cooperative perception, and these information are also injected in order to build a digital twin. In addition to this, we are building a tool sets to deploy and to evaluate the use cases in the test site that we have in IDIADA. And finally, we are also investigating the possibility of extending the cloud continuum in order to include also vehicle in this cloud. So the three use cases, in fact, they are deployed in IDIADA Connected Vehicle Hub in Spain. And this site has 4 sites with different technology going from 2G to 5G. So the network that we are using are basically the 4G network and 5G NSA network, and we are comparing the performance between them. And we have different type of tracks and environment to test the environment for driving. In addition to this, also we have integrated an edge that is directly connected to the network. So for the 3 use cases, the first one is cooperative perception. There we are testing 2 scenarios. We have built a collision warning service in order to evaluate this, and these 2 scenarios are the road stationary vehicle. So in this case, we have a vehicle that is stopped on one of the lanes, and the vehicles that are coming, they will collect the sensory information and send it to the CWS, and this CWS will propagate the information to other car in order to avoid any accident. In the second scenario, we have a zero visibility intersection, where we have an intersection where an obstacle is obstructing the visibility of the vehicle, and these vehicles, through the exchange of informations, they will be able also to avoid accidents. In order to deploy these 2 scenarios, we are using 3 types of V2X messages: the CAM, the DANM, and the CPM. And our requirement or evaluation will be based on 2 main KPIs. So basically the reliability or the success rate of the 3 messages types, and the latency of the data transfer, so the one-way latency. So mainly the challenges that we are also working on are to fine-tune the KPI threshold based on our testing and see what are really the threshold that we want to have, especially based on the speed and the environment that we get. Another also important thing that we are investigating is to map or to have a correlation between network and service KPI. And in order to do so, we are also developing a passive network KPI tool. The second use case is digital twin, and here we are taking one of the scenarios, so the one with the first scenario here, the road stationary vehicle, and we are injecting all the information into a digital twin, so the messages and also the road environment, and we are building a digital twin. So this digital twin also will be used in order to test the different methods or optimization of the message exchanges on a digital twin, so on a simulation, before going to an expensive test site and also time consuming. And finally, we have the predictive quality of service for teleoperated driving, and the objective here is to allow some exchange of information from the network. So we are sending information about cell status and cell congestion, if there are congestion in the cell, to the teleoperated center or to the remote driver. And in this way, in fact, we can avoid sudden braking or reroute even the car to a place where we have a better connection. And as you can see here in the video, we have the teleoperated vehicle that is driven in a good condition. And then if there is a head, so in a couple of kilometers, there is a problem, then we will see, in fact, a warning in the on the HMI for the driver. And we are evaluating this through the uplink or the downlink command latency, the reliability in both direction, the data throughput, and the jitter of the video. So in order to do so, the main idea was to have something like the NWDAF functionality in 5G core, which unfortunately is not available in the network and in most of the network that we already seen. So what we did is that we developed a prediction function, which is basically an exposure interface where the teleoperation center can subscribe and in order to get information from the network. So as you can see here in this figure, we have the teleoperated vehicle that is driving in this blue cell. So we have another car that is collecting information and emulating the NWDAF. And this information will be sent to the prediction function that will send a warning to the teleoperated vehicle that there is a problem ahead. So then the driver, he can either reroute this car or stop it in a very easy way. And finally, we wanted to share also some conclusions that we have from Target X. So we have identified the need to have a digital twin, and this is very important, especially that the test of evaluating V2X application with only 2 cars or 3 cars or 4 cars will not show reality, and we need something with mass deployment of vehicle, and this is only possible with digital twins. The other one is that we showed that the exchange of information between network and application is very important, especially for automotive application, in order to have some ahead information to warn the driver about problems in the network. And the third point is need to deploy network functions like NWDAF, but with higher granularity, because in our case, we were getting some data from the OEM where the granularity is 15 minutes, which is very long for any automotive application. And finally, it's important, especially for the teleoperated driving, is having this mapping between the network KPI driving condition from one side and the service KPIs from the other sides, in order to be able to set the thresholds and any, in fact, requirement for such applications. And this is my final slide. So I'm Jad Nasruddin, and please contact me if you need any other if you have any questions, and you also can reach us on the following link for Target X. Thank you for your hearing.
Okay, thank you, Jad. Very interesting as usual. Thank you very much. So good result for the Target X project. Now we are moving to the next one, which is a TrialNet, and I would like to invite Nina to take the floor and share your slide, please.
Yes, thank you very much. I will start sharing my screen. Okay, can you confirm that you're seeing my presentation?
Mm-hmm.
Okay, thank you. Good afternoon, everyone. I'm Nina Slavnik-Kreštorac from IMEC. I work as a principal investigator in IMEC, and today I will present the TrialNet perspective on automotive and transport and logistics solutions. For those who are not familiar with the project, I will just give a brief introduction, and then I will focus on 2 specific use cases and applications that are.
Sorry, Nina, but my screen is white. I don't know if it's the same for the others, but
yes, I also have the same problem. I only see a blank white screen.
Sorry, I'm sharing, but yeah.
Your white wall.
Let me reshare, so we start again. Yeah, it seems the problem persists. Maybe you can share my presentation if that's not a problem for you.
So, Kostas, could you share?
Here, do you want me to do it? Okay, yeah. Let me.
Yes, please. Yeah.
Okay. Apologies, but I also need to find it, so it should be coming on now and now in presentation.
Thank you very much,
Okay,
Kostas.
very good.
Yes, so yeah, you can go to the next slide. I was just mentioning that I will tackle 2 use cases that are related to the content of the webinar today. One is from the TrialsNet project, and another is from the sub-project that we actually hosted via open call that happened earlier this year. Next slide, please. So regarding the project itself, if you are not familiar with TrialsNet, this is an SNS JU project from Stream D. It was, it kicked off in 2023, and we are now approaching the end of the 2nd year. So we are actually very busy with the trialing activities in the project. But the main goal of the project is to improve the quality of life by testing, trialing, implementation of 5G and beyond applications, mainly. For what reason? Of course, to tackle and impact societal values like sustainability, resilience, inclusion, trust, security, etc. Different applications that we developed, implemented, and now are trialing in the project are falling into these 3 categories: infrastructure, transportation, security, and safety. E-health and emergency, and culture, tourism, and entertainment. There are 13 use cases in total, and we are trialing them at different locations in Europe. We have 4 clusters of trial sites, and each of these clusters is placed in a different country and at different locations with 5G non-standalone and standalone coverage. And the large-scale aspect of these trials depends, of course, on the use case that we are tackling, and of course also on the trial site, but it can mean also the number of real users, like if we have a large number of users, or if the large area is covered by 5G signal, or if there is a lot of data that is being created and also stored for further use, as well as, for example, a number of different network configurations that can be tested in those trials. So the definition itself depends on the context, but all of the use cases, both in the project and in the sub-projects for the open call, are targeting that. Of course, given the content of the webinar, I will focus on the use cases that fall into the first category. So now you can move to the next slide. And I just quickly show the geographic distribution of partners from the consortium. So we are 23 partners with very diverse background, verticals, technology providers, operators, and academia. Now, on the next slides, I will show a little bit of smart highway infrastructure, which is a testbed in Belgium that we use as part of the trial sites in TrialsNet. And there we test advanced 5G enablers for automotive services. So if we move further on the that testbed, actually this testbed is a realistic environment created for vehicular testing or for vehicular communications, V2X. Testbed that helps us create realistic use cases and perform trials. The testbed itself is being used as a complementary setup to the trial site in Romania. But what we do here. So what we do in Belgium. On the next slide, we show some more details about the testbed itself. So that connected mobility testbed is actually deployed on the real highway in Antwerp in Belgium. And we perform research and development activities over there before moving the enablers or the new technologies to the real trial site somewhere else in the project. For example, in this case, we are contributing to the use case on smart traffic management, which is being mainly trialed on the Romanian cluster in Bucharest and Iași. So what we do is we test ultra-fast connectivity, distributed computing with these roadside units that are deployed on the highway stretch, which is around 4 kilometers long. And we have around 8 roadside units that are deployed there that can host both computing resources and also the connectivity devices to enable vehicles like the test vehicle that we have to connect to the automotive services running over there. On the next slide, I will talk about the zero-touch service management, which is exactly the enabler that we test in Belgium. So before actually moving this to the trial site location and testing this advanced orchestration on the automotive service for smart traffic management, we actually develop it first and test it in this testbed environment. So we collect data from the computing environment, from the network itself, from the users as well, and we process that data using rule-based or more sophisticated machine learning models to learn, for example, the resource utilization, mobility patterns, et cetera, et cetera. So these small services that are intelligent are contributing to the decision maker that is making a single decision on what to do with particular automotive service, or it can be any other, but we are considering here also the use case performance requirements of automotive that can be very stringent in terms of end-to-end latency, throughput, reliability, etc. Once the decision is made on whether to do the scaling or migration from one edge computing system to the other, that decision is being deployed, and then we can see the impact on the real performance of the use case. On the next slide, I will show you the application that we are actually testing here. So smart traffic management application is part of the use case, which is jointly developed by Orange Romania, Technical University of Iași, and we from IMEC are also contributing with this zero-touch service management to this particular use case. This use case is has very stringent requirements in terms of end-to-end latency and reliability, because apart from the vehicles, vulnerable road users are also involved. And here on this dashboard, for example, they also show different events that can happen, like collision events between the vehicles and the vulnerable road users, which is something that requires fast reaction from the network and also sufficient network quality at every moment. So what we do with this zero-touch management solution is to place the application at the optimal location and to make sure that the application has enough resources at every moment of the operation to ensure that these KPIs are being met for the specific use case. You can go further. There is also, this is a video, but I will also provide the link to the YouTube channel of TrialsNet, so you can also check all these videos that we recently presented in one of the review meetings. On the next slide, I will just show the dashboard of the zero-touch service management framework. Basically, what I briefly summarized is that the decision maker logic in the zero-touch service management orchestrator is deciding where to place the service, on what roadside unit, on what edge computing node. So in this case, different parameters are being taken into account, like latency, CPU memory storage, but also power consumption, because we are trying to tackle the environmental sustainability component here by trying to reduce the power consumption on different edge computing infrastructures. So the decision here is made, for example, that the service should be placed on the roadside unit 7 because it offers the lowest latency to the end user, to the vehicle, but also it is currently consuming the least power from the other compared to the other roadside units. This is a very tunable framework, and we are working further on it, but just showing some current progress and results that we achieved so far. I will just also now on the next slide present one of the use cases from the open call. This is automated teleoperated sustainable driving, or ATOS driving, how we call it. So the use case is about teleoperated trucks that are using advanced 5G network exposure capabilities, like quality of service on demand that was already mentioned by the previous presenters. And the truck itself, or the teleoperation service, is capable to adjust dynamically the quality of service in the network as per different events that can happen. And also it can subscribe to network performance metrics to analyze them, to make the teleoperation service network aware, so that the safety of the teleoperation process can be improved in any case. On the next slide, I will also show the KPIs and KVIs that we focus on in this sub-project. So the teleoperation related KPIs are the ones that are on the application side. So for example, Vitron and RoboAuto, the companies that are working on the teleoperation providing that technology, are measuring different latencies, service reliability that are very important for the remote control itself. But on the network side, for example, TNO, who is also leading this sub-project, is measuring different KPIs that are further linked with the application KPIs to learn the relationship and learn how the network is actually impacting the application. And of course, KPIs are a very important part of all SNS projects, including TrialsNet as well. And here, societal and economical components are tackled from the perspective of driver shortage in Europe. So if we have safe teleoperation enablers from the network that are creating more safety for the teleoperated driving, we can improve both the, for example, work-life balance, but also the driver shortage in Europe. And environmental, the partners are tackling that from the perspective of energy usage reduction. On the next slide, we show the architecture, the infrastructure view. So basically the teleoperated vehicle is connected via 5G standalone network, and it can also use teleoperation service that is running on the cloud or on the edge. And that service is triggering or using the quality on demand API that is exposed on the 5G core to dynamically trigger changes on the quality of service in the network. For example, if more bandwidth on the uplink is needed to achieve higher throughput for a better video quality, then the teleoperation service can trigger that itself. But also on top, we have the orchestrator, the zero-touch service management that I mentioned on the previous slides. So that one is also considering different requirements that are coming from the teleoperation service, depending on the specific latency, throughput, reliability values, and it decides where to place that service on the edge, on the cloud, on which particular location, and how to enable the optimal performance of the services so that the vehicle, the teleoperated vehicle, can be driven in a safely manner. Some of the preliminary results that we achieved, actually the partners from this sub-project achieved, are shown on the next slide. So what can be already seen from the preliminary test that they did is that the RTT values and the uplink throughput are met, the requirements are met for the teleoperation, but it's important to highlight here that this is only tested for one vehicle, and this is also showing that not 100% of the time the values are under the threshold. So it is important to note that the use of quality on demand here is very important, because in these edge cases, the quality can be dynamically changed in the network. The network resources can be given to prioritize this specific traffic because having higher latency or lower throughput can be fatal for the teleoperation of the truck. This, I think, also reinforces some messages that were shared by Jad previously, when talking about using these advanced enablers from the network, and also using more diverse testing requirements and testing conditions to show the capabilities of the network for the 6G applications. This is all from my side. My contact details will be also available, and you can contact me if you have any questions, or I would like to answer them today as well. Thank you.
Okay, thank you, Nina. Very good. Okay, so we are right in time with regard to the agenda. So I would like to invite Guillaume to take the floor and share your presentation. Thank you, Guillaume.
Yes, I'm trying to share. Can you hear me?
Yep.
Okay,
Let's
excuse
see
me, I'm
your
trying
screen
to.
yet.
Yeah, I'm trying. It's I'm not completely. Yes. All right. Yes. Is it in
Okay.
full screen?
Yeah.
Okay. Thank you. So my name
it's
is.
It's not in full screen. It's in normal screen.
It's in full screen on my side, so I don't know. Is it working now?
Not better. But okay, so maybe you can.
Now, I am in full screen on my side, so I don't know.
Maybe you are not sharing the right screen. Maybe, I don't know.
What am I sharing? Okay, but sorry, I on the web version, so don't know if I can do better than this.
Okay, let's try again, and if not, so we will continue that way.
So yeah, just tell me, because there is some bit of latency. Otherwise, but do you see my slide, or
No,
at least?
not at all at this time.
Okay. Why don't I share your slides, Guillaume?
Yeah, sorry, please. Yeah, please.
I have the PDF version though, so hopefully you should be seeing them now.
Yeah.
Okay, please go ahead.
Okay.
Guillaume.
Let's go. Yeah. So my name is Guillaume Journeau. I'm working for Bosch as a research engineer, and I'm also the lead for the work package 5, which is the proof of concepts and demonstrators in the 6G DISAC project. So thank you for this opportunity today to present, give you an overview of the project, as well as the use cases that we will address. And I will particularly focus on the automotive one. Can you go to the next slide, please? So 6G DISAC is an Horizon project. We are almost at the end of the first year. We will start in January with the WP5, so the proof of concept and demonstrators, and then this will run for 2 more years, so 3 in total. We are 10 partners from 5 countries. We have Commissariat à l'énergie atomique in France. We have Chalmers in Sweden, Nokia France, Telecom Italia, Orange in France too, KUA in Greece. We have IMS University in France too, NEC and Bosch in Germany, as well as Ratchet in Sweden. Can you go on the next slide, please? So the DISAC, 6G DISAC vision is to go from ISAC, classical ISAC, integrated sensing and communication, to semantic-aware distributed ISAC. So on the left part, we have the classical ISAC with monostatic sensing, with single target scenarios, with local processing at each base station. We have the possibility to also do bistatic positioning, and we have the handover of connected devices. So thanks to three main technologies or main features, we want to address a plurality of technologies. So we have a distributed architecture, which allows us to do distributed processing, to use multiple base stations, to do the sensing, and to do also handover of basic objects. Thanks to semantic and goal-oriented framework, we can do semantic sensing. We can also do semantic communications with supporting AI algorithms that allows us to also achieve this high resolution and this processing of all this data that is locally stored and computed, but then distributed over the network in order to do fully distributed mode. We can achieve also super resolution distributed signal processing, also thanks to this AI, to those AI algorithms, and to some advanced in waveforms within this DISAC framework. We are also studying, or we are also using technologies such as reconfigurable intelligent surfaces in order to achieve the right propagation and optimize the signaling. So if you can go on the next slide. Yes, thanks to, so I will now go a bit deeper in our architecture. So we have, as I mentioned, an intelligent distributed processing. So you can see this in all the arrows where we exchange, on the one side, processed data from the local data processing units at the base station towards the fusion center. And on the other side, we send some control, especially interesting for the RIS, as well as the specific beams that we use to do the sensing. So we have from base station sensing signals that are sent and also received after reflection on the targets. We can optimize those signal exchange thanks to the control of the reconfigurable intelligence surfaces. So what we try to achieve is to have to integrate the different sensing nodes that are rather heterogeneous, because we have, on the one side, we have the ISAC base stations. We also have onboard sensors, and we also aim at using the sensors in the infrastructure. In terms of waveform and signal and reflection of signal, we want to use large MIMOs and optimize the sensing thanks to the RIS control. And finally, we want to use some semantic layers that allows us to do, on the one side, sensing-aided communication, but also communication-aided sensing. So the first one, we sense the environment, and we then optimize the communication to the reflection environment that we have sensed. And on the other side, we use the communication in order to share the different sensed raw data from one base station to another. So if you can go on the next slide, please. So we have two use cases in 6G DISAC. The first one is the smart factory shop floors. Here we will first focus on one node. So we have one automated guided vehicle that is driving through the factory floor. This AGV is sensing its environment with its own sensor and needs to establish a dynamic map of the environment in order to do the task that it has been allocated. So what we want to do based on this storyline is to do a real-time and collective building of the dynamic map of the environment from multiple AGVs. We want to do efficient task allocation thanks to the detection, the identification, and mapping of different obstructions, objects that are on the way. And we want to demonstrate all the different algorithms that has been developed through the project. Particularly, we want to develop radio SLAM for those AGVs. So here we want to demonstrate that with DISAC over classical ISAC, we can use like different modalities of sensing, that is from the base station, but also from the AGVs themselves. And we want to show that we can do an efficient mapping of the dynamic environment. So particularly, we want to leverage the fact that thanks to the distribution of the base stations, we can avoid different obstructions of the field of view thanks to the overlapping of complementary field of views. Can go to the next slide, please. And then we have a second use case where it's been already mentioned before, smart intersection. In our case, what we want to focus on is the vulnerable road user protection. So those VRUs, they are sharing the environment with the vehicles. That is, we have particularly bicycles or pedestrians, and we want to make this smart intersection safe. And for this, we want to leverage what is already there. That is some traffic cameras in the infrastructure and the onboard sensors. So currently, if we just take this intersection without the exact system, we don't use communication with the communication infrastructure, neither for the sensing or for the sharing of information. So the goal here is to use DISAC in order to identify those VRUs and to localize them. And after that, what we want is to use this information from the communication-based sensing with the onboard sensors and the camera, for instance, the cameras that are in the infrastructure. And here, what we are particularly interested in is the fact that we can fuse information from different sources, and here the onboard sensoric as well as infrastructure sensoric. And I will go a bit deeper in this in those technologies in the next slide, please. Yes, so the challenges that we are facing in this use case is that we want to do real-time sensing. So we need to continuously send and adapt the traffic management because we want to protect those VRUs also using the red lights and the different ways that we can, like different actuators that we can use in the intersection. So we want to implement safety protocols that are prioritizing those VRUs, such as activating a pedestrian crossing signal when one pedestrian is detected. And finally, we want to do this in a rather low latency communication, since we need to react very fast for some new VRUs detected and some potential collisions that is detected by those algorithms. In terms of technical implementation, we want to integrate this smart traffic management within the DISAC system as an application that is first taking advantage of the sensing capabilities of the DISAC network, and then also sending the commands or the control to the actual actuators of this smart intersection. We aim at deploying the sensors and using the sensors that are already on board. So we have LiDAR, we have radar, we also have video cameras, but we also have, generally abstractly all environmental sensors, and the ones that are also in the intersection, the ones that are in the vehicles. And we want to leverage the fast communication of the 6G or 5G, 6G network in order to get those sensing signals, and information, and distribute the control information. And this will be my final slide. I would like to thank you for your attention. We have here for offline questions, you can contact me, or you can contact the project coordinator or the technical manager. Follow us on Twitter or directly see the latest news on our website. Thank you.
Very good. So very good. Thank you. Thank you for your presentation. So now it's so as Maxime has not been able to join today, so I think that we have 10 minutes above us to have some question of answer. I did not see any question yet on the chat, but it's still open. So if you have one, do not hesitate. So I don't know if others on the chat, you can. One of you is willing to ask a question to one of the speakers.
In the meantime, many thanks to David for already uploading the slides in the event page. So many thanks, David, for already doing that. And many thanks to all the presenters. It's interesting to see that we have both dedicated projects looking for solutions, also some projects that are using automotive and transport logistic use cases as a means to validate some of the new features expected with beyond 5G and 6G. Yeah, it would be interesting to get into a discussion, how do we see this progressing into the next phase, which is the deployment phase that CEF and the Guide project are sort of provided an overview. But it potentially is a little bit early for this as well. Since I also don't see any questions at this stage, maybe Pierre, would you be okay to give the floor to David to maybe
sure.
introduce the next phase of CEF? How about that?
Yes, please, David, if you can share your screen and make a short presentation of the next call of the CEF program, which is also addressing automotive and transport and logistics.
Okay, it's just the share button doesn't seem to be responding. I'm not the, I see, sorry, yes, it's hiding all sorts of content. Okay, let me see. That should work.
Yes, it's coming.
Yes.
Okay, thank you.
Great. As always, WebEx has changed my screen view, so I'm not totally sure I see what you're seeing, but okay. Very quickly, Kostas, Pierre, thank you for setting up the session on that. I just want to add a little bit of a comment because you have highlighted projects from two different streams of work. One from the CEF approach, which is trying to facilitate the rollout of the 5G, and the other from the SNS JU activities, which are trying to progress beyond the 5G PPP achievements into 6G. And both of these streams are going to continue in the next period. So very quickly, just for our audience that are still there, the 5G corridors activity as we knew it is being merged into a new approach in call 4 called 5G large-scale pilots. And it basically brings together the 5G coverage along the transport corridors and the 5G edge and cloud for smart communities. Now, the ambition is still the same. They want bigger projects. They want 5G rollout things. In the 5G coverage along transport corridors, it was aimed at enhancing the 10T network, particularly in the cross-border scenarios. I believe they're a bit more flexible now on what it means in cross-border, and actually coverage along the whole route can be covered a bit more, provided there is some cross-border dimension. And similarly, the 5G edge and cloud, some of the issues are more to get more use cases involved. Money-wise, there is a lot of money in this. It's on the table. There's 105 million for the experiments under large-scale pilots. So anyone who has the ability to roll out 5G applications and that, please have a look at this. Key point, they're focusing more on work projects, no longer on studies. So we have to work out where we get the works proposals from. You should be at the implementation phase. You can still include a little bit of a study in a works project, but the focus has to be on the implementation activities. Timeline is short, particularly for implementation type projects. 13th of February is the deadline. So please, if anyone's thinking about it, talk to the CEF officers, talk to anyone you can, and work out how you can submit. I won't go through the call parameters in the interest of time. Just simply think about it, read the slides offline, and you can follow that up. The links are there in this last slide to the specific topics. And again, the key word will be implementations. Priority will be to support investments in cross-border sections, but they will allow more of the national infrastructure to be involved. It doesn't have to just be the bit at the border. And in the 3C, the idea again is to just get the applications. We're looking for more links to the application domains in this. So that's really worth noting. This is being mirrored in the 6G development in the SNS. They're looking how the application areas will use 6G. Here, they're looking for the application areas to show some interest in the take-up of 5G. So the experiments should work that way. I'll stop there in the interest of time. Thanks, Kostas. Thanks, Pierre-Yves.
Okay, David, there is a question in the chat regarding the level of funding, for CEF project.
Yes, the level is 50% on these. The idea is that you basically are investing. The logic, sorry, just clear my mind. The logic behind the CEF program is that there are areas where the rollout is not naturally happening because there isn't sufficient market interest. to make it happen. Therefore, they are looking for a way to address these areas where the market is failing. So they're not paying for everything, but they will pay up to 50% to, how will I say, kickstart the activities and help it happen. So the capital expenditure needed to introduce the infrastructure and all that is reduced, and hopefully that will be sufficient to support the business models. The key point in any CEF project is consider your business model, consider the investments that have to be made, and see, with the additional funding from CEF and that, can you come up with a viable business model for the future services?
Okay, so I think it's all I got in the chat at this time. So we are more or less close to the end. So Kostas, maybe a last word.
Yes, thank you, Pierre. Thanks again to all our speakers and the audience. So hopefully we managed to give you an overview of who's working on what when it comes to research and innovation or solutions beyond the current deployments, but also for the deployments of 5G. So hopefully you have the correct contact points. We did hear about also a few projects having some open calls that you may apply for. We also heard about the fourth call of the CEF program on the automotive. So there are funding opportunities out there, and hopefully today's event has helped you pinpoint them. Do keep in touch. All the slides are on the event page already. The recording of this event will also be there for your colleagues that might be interested and could not join us today. And with that, I thank you again all. Give maybe the floor back to you, Pierre, to close the event.
Mm-hmm. And if you have any late questions, do not hesitate to send a mail to me or Kostas, so we'll be happy, to answer them.
Yeah.
Okay.
So thanks, everybody. Have a good afternoon.
Yeah. Bye-bye.
Thanks, Kostas.
Thank you.
Bye.
Bye.
Thanks, guys.